Welcome to the history of astronomy.
Mesopotamians developed the early calendar. The Mesopotamian calendar was primarily lunar, and the months began with the first sighting of the young waxing crescent moon just after sunset on the western horizon. They also had the idea of 360 degrees in a circle.
Mesopotamians were also the first to make one of the first observation towers called ziggurats. They used these to have a better look at the night sky. Mesopotamians also created the concept that a circle has 360 degrees. Another group of astronomers around the same time were the Egyptians. The Egyptians created the calendar to mark when year and what time the Nile would flood. They also built their pyramids and structures based off of the lining of the sky and stars and planets. Around the 13th century, the Chinese were also doing astronomy. They were studying solar eclipses, comets, meteor showers, and gas stars. One of the most famous sightings they found, which was a comet, which would be later named Halley's Comet. Later in time would come a group of Greek astronomers that would really revolutionize astronomy. One of the first was a merchant named Thales. He traveled to Egypt to learn about astronomy from the Egyptians. When he came back to Greece, he was one of the first Greek people to be able to record solar eclipses. Astronomy was completely revolutionized when Pythagoras came out with this version of the solar system. It showed that all planets rotated in a circular pattern around the sun. They do this because they're shaped as spheres and not flat. Many people challenged and criticized Pythagoras because many people were convinced that the earth was flat. Despite controversy, this inspired the Babylonians. They made a calendar to track the movement of the moon and sun based off of Pythagoras' idea. Pythagoras was also backed up by Aristotle, who claimed that since the earth is round, all objects fall into its center. The circular shadow on the moon is the earth's shadow, and if the earth was flat, stars in Egypt could also be seen in Greece, which is not the case because the earth is round. Math would also make its way into astronomy. Aristotle was the first to do so by using geometry to find the distance from the earth to the moon. He also used lunar eclipses and used their pattern to determine the linear diameter of the moon and earth. The person that would confirm and find out the actual size of the earth, though, would be a man called Eratosthenes. Hipparchus used Aristotle's method to determine the distance from the moon to the sun. He also concluded that the earth, moon, and sun always forms a triangular pattern no matter how they are revolving around each other. Astronomy was also big in Mesoamerica, especially with the Mayan Empire, who lived around Mexico and Guatemala from 1,000 to 2,000 years ago. Like the Egyptians, the Mayans built their buildings based on the stars in the night sky, especially positioned by the summer and winter solstice. They also created a very complex calendar marking just the rising and the setting of the sun and moon, but also the planet Venus, which is what they worshipped. They were able to keep track and predict where the planets rose and set because of a Greek astronomer Ptolemy's model of the solar system. His model of the solar system was an in-depth detail of where every planet moved. Ptolemy didn't just invent this himself. He also concluded that the Earth was stationary and did not revolve around anything, but was the center point for all the planets revolved around. Of his time, this had inspired many other astronomers to make their own solar systems later on. Helped with the astronomy movement. They improved many observation techniques and the way people recorded planetary positions. They did this by traveling to Spain and Asia and other places to work with many astronomers and talk about how they could make the way people record things in the night sky better. They also took Greek astronomy techniques and translated them into Arabic for their own people. These Islamic records would spread to Europe, which would cause a huge explosion of European astronomy. One of the biggest European astronomers was a Polish astronomer named Copernicus. Copernicus made the heliocentric model. This was huge because this was the first planetary model which no planet revolved around the Earth except for the moon. He chose the sun to be in the center where all planets would revolve around it. Copernicus also created special laws of motion for each of the planets. Even though most of the original planetary solar system was changed, he still accepted the fact that all planets rotate in a circular pattern. Copernicus's model or Ptolemy's model will be debated for a while about which one is truly right, until Tycho Brahe, a Danish observer and astronomer, came to compromise both of those. His solar system model included that the sun and moon would revolve around the Earth. However, every other planet would revolve around the sun. 3 years till his death, Brahe met an expert in planetary motion known as Johannes Kepler. Johannes Kepler was famous for making his own laws of planetary movement and motion. Kepler's first law states that a planet moves on an elliptical orbit with the sun at one focus. His second law said that planetary motion moves in an imaginary line connecting the planet to the sun, sweeps out equal areas in equal intervals of time. And his third law stated that all motions of every planet is connected to each other, which means that one planet has to rely on another planet's motion in order for it to move.